So this was the original design we were looking to get around, and mine looked a lot different in the end, just because I went with a different gear ratio. We had trouble getting over the ramp with that larger 60 tooth gear in between the 32 teeth gears. When it comes to the code, we really just defined a lot of stuff in the beginning for our liquid crystal package. Also, make sure to define our servo motors. Right here, we're just defining our pins for our motors, our left and right motors. And we're also declaring our LCD display there, just making sure we know what it's saying. In our main loop here, you can see how repetitive it is. Basically, we start off stopped for 4 seconds, move on forward. I measured out how far I can go per second, and decided how, measured the course out per turn, and that's how I came up with these delays for our forwards. Also, I timed how long it takes to twist and turn at a 90-degree left and back right, so yeah, that's where I got those delay numbers. I did have to change most of them due to the battery dying halfway after a few tries. Um, Really, this is just straightforward. You stop, go forward, stop, turn left, go forward, stop. It's really simple, very repetitive, as you can see. It does, I literally copy and pasted each 4 lines right there, just changed the numbers, which made it pretty easy for me.
You son of a bitch.
So this next piece of code for the second part was very interesting. Did a lot of research for this one. The beginning was similar, although we had to, define a lot of different variables like our button count, our last button state, and our button state. We're going to use this for logic later in the code. The unsigned long value took forever to figure out how to use, and we'll get to that here in a second. If we look into our setup, it's very similar. Then we have our serial begin, which that's just going to count how many number of buttons pressed we have, just so I can keep track, and do some troubleshooting with that. Other than that, we still have our LCD AACC mechatronics showing up just the same as the first time. So the first if statement we're going to start, I believe this is called a nested if statement, having an if within an if. We're going to use some, not math, but I guess we're looking at the differences between our button states. If our button state is high and our button count counts up 1, we're printing in the number of buttons pressed, and we're delaying going into our first real if sequence to control the motors. So we're going to start off with the motors stopped, delay a little bit. I decide to turn left first. This was actually, looking back on it, not the best idea, but it works out in the end, so it's really okay. Just turn left first. Make our stop. Down here is where you can see the unsigned long. The current time equals milliseconds if unsigned long is greater than, if unsigned long times current time minus previous time is greater than our time check. Our button count goes back down to 0. We're going to add an else if statement down here that's going to cause the 180 This 180 turn will only be triggered if the button count equals 3. This, looking at the maze at first, you run straight into a wall, you make a left turn into a wall. After that second wall, you do make another left and run directly into another barrier. That is what triggers the 180. And the delay value for that 180 was just, I took the 90-degree turn from the previous code and doubled it. Of course, it changed a little bit just from the battery loss and what have you, but otherwise it's the same. And we use the same math down at the bottom. The previous time equals current time is just an easy way to reset our counter. And then we delay forever.
I was showing some of the Mech 140 videos from last year.